Hello students, good evening. Welcome to another video of Vedantu Karnataka. This is Catherine, your physics master teacher. I'm really sorry, I'm a little late. My system was not working properly. I had to figure it out. Now if it's working properly, let me check. Can you let me know if it's working, if I'm audible and visible? Okay, right? Yes. Students, as you've all seen the thumbnail, today we're going to discuss two markers. Okay, so we're going to discuss two markers from all the chapters that are going to be there for your midterm. Okay, all the markers, all the chapters, very important, two markers. So if you join with me, we'll be doing two markers. Next class we do three markers, five markers, everything, fill in the blank, MCQs, everything. Okay? So I'll make sure each one of you prepare so very well and crack your midterms with, what do we say, flying colors. Yes. So, yeah. Good evening, good evening. Good evening, Chinese world. Good evening, Vanak Vanakkam. I'm not able to pronounce your name. Really sorry. Good evening, Sushmita. Good evening, Maruti. Yes, G. Mr. G. Can I call you Mr. G? 2 marks, most important questions we are going to discuss today. All 2 mark, most important questions. Yes. Okay, students, quickly, before we start class, I want all of you to send this link to all your friends. Everybody send it to your class group, send it to all your friends, tell them, let us prepare physics with Cathren Ma'am. Okay? So quickly, all of you send this to all your friends. We're going to start with 2 markers. First chapter, units and measurements. Okay? So 2 markers from units and measurements. Yeah? Did you all send the link to all your friends? All your groups? Ready? All of you ready for 2 markers? Okay. First question, very easy question. What are basic units? Give one example. That's a very famous, common 2 mark question. Just what are basic units? See, basic units are the same as fundamental units. Remember, I already taught you this. What are fundamental units? Fundamental units, units that are used to measure physical quantities like length or weight or things that you don't derive. So for example, if you look at force, the unit of force is a fundamental. Explain it. Please give 2 marks important. Yes. 2 marks important questions I'm giving. Okay. Yeah. Okay. So if you look at units that are derived from fundamental, for example, let's say force, as I said. Okay. So force is something derived from mass and acceleration. But mass is a fundamental unit because you don't derive mass from anything. Acceleration is not a fundamental unit. Why? Acceleration is derived from velocity by time. Time is a fundamental unit or a basic unit. Okay. So basic unit means basic. It is used to measure fundamental quantities. It cannot be derived from other quantities. You cannot derive them. Okay. Yes. You're not able to see what I've written, no? Now can you see? Yeah, now you can see. So question 1, what are basic units? Question 2, write the SI unit and dimensional formula for moment of inertia. Okay? SI unit and dimensional formula for moment of inertia. So to write this, you need the formula for moment of inertia. I is equal to mr square. Yeah, I is equal to mr square is the unit formula for moment of inertia. From this we can write down the unit. What is the unit of mass? Kilogram. What is the unit of r? R is basically distance. So distance is meter. Meter square. Now how will I write the dimension? Dimension of mass is m. Dimension of meter or dimension of length is L. So ml square. Okay, so the answer is the SI unit is kilogram meter square and dimension is ml square. That is the answer. Okay, yes. Okay, next question. State the principle of homogeneity of dimension. What do you mean by state the principle of homogeneity of dimension? Principle of homogeneity means the dimensions on both the sides should be the same. Okay. For example, B, let's take for example, B is equal to U plus 80. Okay. Let's write down the dimension. What is the dimension of B? L t raised to minus 1. Okay. V is velocity. Velocity is distance by time. Distance is L divided by time is t. L by t. L t raised to minus 1. The unit of u, dimension of u is also L t raised to minus 1 plus the dimension of acceleration is what? L t raised to minus 2. Acceleration is velocity by time. Okay. Now what is the dimension for time? T. So t raised to minus 2 into t. This will become t raised to, can I write t raised to minus 2 into t? Can I write it as t raised to minus 1? Yes. Now you can see on the LHS and the RHS, all the terms have the same dimension. So this is principle of homogeneity of dimension. Okay. The equation is dimensionally correct. So terms on the left side and the right side have the same dimension. Okay. Yes. Hi Manoj. Hello. Ma'am, SI unit formula what, ma'am? SI unit no formula. SI unit means unit of that one quantity. Like for example, length. Unit of length. SI unit of length meter. Okay. Mass. SI unit of mass kilogram. SI unit of what else? Force Newton. Okay. Is that your question, Mr. G? Yeah. Okay. So principle of homogeneity of dimension says that the dimensions of all the terms on both the sides must be the same. Okay. So equation should be dimensionally correct. Next question. Give any two limitations of dimensional method. What are the two limitations of dimensional method? First one, with dimension, you can't find out the dimension of numbers. You can't find out the dimension of pi or coefficients. All of these things you can't find dimension. You can only find dimension for things like mass, length, force, acceleration, quantities like that. You can't find dimension for constant values. What are constant values? Values that have a single number. For example, pi. What is pi? 3.14. Pi is a constant. You can't find the dimension for constant. Let's say a number 5. 5 is a number. You can't find dimension for number. Okay? First point. Second point. It cannot be used to prove correctness of an equation involving vector complex quantities like trigonometric functions. For example, I cannot prove if sine square theta plus cos square theta is equal to 1. I cannot prove if this equation is correct using dimension. But if the equation like this, then I can prove it using dimension. So I cannot prove equations with trigonometric functions or exponential using dimensions. Okay? E raised to x is equal to something. That equation I cannot prove using dimension. So those are the 2 points. First one, you cannot find dimensions for constants. You cannot prove the correctness of an equation that has a trigonometric function or a vector or an exponent using dimension. Okay? Okay, Manoj, laws of motion, important questions I will do. Okay? What's the lecture? Lecture, chapter by chapter, all the chapters that are there in midterm, I'm going to do. Okay? Yeah. Next question is now motion in a straight line. First question. Okay, so these are the basic questions from units and measurements. Basic units, fundamental units, derived units. They will ask you some random question to find the SI unit dimensional formula of some random quantity, like moment of inertia, principle of homogeneity, limitations of dimensional analysis. Okay. Next, we'll move on to the next chapter, which is motion in a straight line. So, first question from motion in a straight line. What is the question? Work energy power every chapter till gravitation we will do. Okay, don't worry. Motion in a straight line. 2 markers. Write any two difference between instantaneous speed and instantaneous velocity. Students, the speed and velocity, what is the difference? So if you say your speed is 20 meters per second, okay, and let's say to find out velocity, what will I do? I will say it is 20 meters per second to the right. Basically, with speed with direction is velocity. Okay? What is the difference between speed and velocity? Speed has only magnitude, velocity has magnitude and direction. Yes, Xavier, these are all sure questions. Okay, these are all from previous year papers and from your field board. Okay, so you can rely on these questions. All right. Now let's look at what is this is speed. What is speed and velocity? I just explained now. Now let's look at what is instantaneous speed and instantaneous velocity. Okay. So instantaneous speed, as I already said, it has magnitude, no direction. Okay. But instantaneous velocity has both magnitude and direction. Okay. Instantaneous speed is always positive. See, your car can't go in a speed of -20, isn't it? Your car can move only in positive speed. But instantaneous velocity can be positive or negative. How can it be negative? Because it isn't dependent on direction. So let's say if you're going forward, the velocity is positive. If you're going backward, your velocity is negative. Okay? Hi, Vikar, Vichar. Today's world, come back fast. Okay? Yeah. Okay? So instantaneous speed has magnitude and is always positive. Speed cannot be negative. But instantaneous velocity has magnitude and direction. It can be positive and negative depending on the direction. Okay? Now, what does instantaneous speed tell us? It tells us how fast an object is moving. So if you say you are driving your car at a speed of 20, it means how fast you're driving. But instantaneous velocity tells you how fast you're driving and in which direction you're driving. Okay? It tells us two things. Okay, next question. Draw position time graph. Position time graph means time here, position here. Okay? Position time graph. Body moving with constant speed. Or a body moving with constant speed. How will you draw the position? So, position time graph for a body moving with constant speed. How will you draw that? So, since the body is moving with constant speed, its speed should not increase. Yeah. Okay. So, the graph will be something like this, right? So, let's say this is 2. Can you see my 3, 4? So, this is also 2, 3, 4. In the first 2 seconds, it crosses 2 meters. In the next 1 second, it crosses 1 meter. Next 1 second, 1 meter. So, every 1 second, it's crossing 1 meter. Okay. So as position changes position and time changes at a regular interval equally. Okay, every 1 second, 1 meter. That is because speed is same throughout. Yes? You understand? Now, dimensional means what? Dimensional means, hmm, okay. So for Mr. G, I'll explain what is dimension. So mainly we have three dimensions. Okay. The first dimension is mass. The second dimension is length. The third dimension is time. Okay. Now every quantity you can represent with respect to these three. Okay. For example, let's say velocity. Velocity is what? What is the formula for velocity? Distance by time. Now, distance is a fundamental quantity, which means it's like a basic quantity. Distance is not derived from anything. See, velocity is derived distance and time, but distance is like a basic quantity. Now, what is the dimension for distance? Distance is what? Length. So, dimension is L. Time is what? T. Dimension is T. So, this is L. I will take T to the numerator. L T raised to the minus 1. This is dimension. Okay? Yeah. So Mr. G, what you can do is you can watch my video on chapter 1, units and dimensions. There I've done a lot of examples for dimensions. Okay? You can just go to Vedantu Karnataka channel and watch that video. It will be clear to you. Okay? Alright. Is this clear? Yeah? I don't see anything. I have some response in the chat. Okay, next question. Draw a position time graph for a body moving in positive direction with negative acceleration. How will you do that? Negative acceleration. So you should have position, time, and your graph should show acceleration. How will you do that? Quickly let me know in the chat. Quickly. How will you do that? So that will be your homework. Okay, I want all of you to find out how to draw position time graph for negative acceleration. I already showed you how to draw position time graph for constant speed or constant velocity. Now, if it's acceleration, what should happen? It should increase. Yeah, so it should be a curve. Now, how should the curve be? That you let me know. Okay, next question. Define average velocity and uniform velocity. Average velocity and uniform velocity. So, average velocity is equal to, what is velocity? Displacement by time. Simply chumma velocity is what? Displacement by time. So average velocity is total displacement by total time. Okay. Now we can understand from that we learn how fast an object moves and in which direction an object moves. All that we can get to know. This is average velocity. Now, what is uniform velocity? Uniform velocity is when an object moves in a straight line with constant speed and fixed direction, which means velocity is not changing with time. Okay, Chinese world is back. Welcome back, Chinese world. Yeah. What does that mean? So this is A, this is B, this is C. From A to B, the velocity is 3 meters per second. From B to C, also the velocity is 3 meters per second. Every time the velocity is same, that is uniform velocity. Okay? Average velocity is the velocity need not be same. You just take total displacement divided by total time. Okay. Next, it's a mathematical question. Very easy question. I mean, these are 2 marker students. They have to be easy, no? Yeah. A body moving with an initial velocity 5 meters per second. Which means U initial velocity is 5 meters per second. Uniform acceleration A is 1 meter per second square and time is 20 seconds. We have to find out the velocity. Capital letter V is what we have to find. Very easy. What is the formula? V is equal to U plus 80. U is what? 5 plus 1 into 20, which is 25 meters per second. Easy peasy. Yeah. So for 2 markers, all the questions that you get, 2 markers will usually be very easy. Yeah. So please make sure you attend to those. The velocity of a body is said to be uniform. Yeah, if it covers equal distance in equal intervals of time. Very good Chinese word. That's great. Okay. So uniform velocity is when a body covers equal distance in equal intervals of time. Very good. Okay. Next, let's look at some questions from motion in a plane. Chapter 3, motion in a plane. Okay. Yes. Are you all ready to do chapter 3, motion in a plane? Ready, ready, ready? First question. Define scalar product of two vectors. Give an example for scalar product. So scalar product is what? Scalar product is basically dot product. Yeah. Scalar product is dot product. Okay. So scalar product of two vectors A and B is equal to A dot B. Okay. The scalar product of A and B is A dot B, and A dot B is equal to AB cos theta. Okay. A dot B is equal to AB cos theta. Okay, that's clear. So scalar product is obtained by multiplying two vectors A and B and the cosine angle between them. I've already taught this to you when I did a chapter. I don't maybe last chapter, maybe work work energy power. In that chapter, I taught dot product. So this is A, this is B, and this is theta. So A into B and cos of the angle between them gives you dot product. Okay. Now, this also the question asks for an example. What is the example? Work done is what? F dot D. That's why I said in work energy power, I've taught you this. So to teach you W is equal to F dot D, I taught you what is dot product first. So this is what? F D cos theta. Okay. It is F D cos F D cos theta. Okay. Yes. Okay. Write expression for resultant of two concurrent vectors A and B and explain the terms. Okay. So I have to write down the expression for resultant of two vectors. How will I do that? So the resultant of any two vectors, let's say two vectors A and B, the resultant of the two vectors is basically A square plus B square plus 2AB cos theta. Okay. So A and B are the magnitude of the vectors. Theta is the angle between them and R is the magnitude of the resultant. Okay? Yes. Next questions are questions from projectile motion. In case 2 markers, you definitely won't get derivation. So what will your questions be? It will be to give expression. So what is the question? First question. Write expression for Find slide of a projectile motion and explain the terms. So what is the expression? T is equal to 2u sin theta by g. Okay. So the expression is T is equal to 2u sin theta by g. So what are the terms? What is u? U is initial velocity. Theta is the angle of projection. And g is acceleration due to gravity. Okay. Yeah. Next question. Write the expression for range of a projectile. So all these how to derive I've already done in my classes. My theory classes, you can just watch those videos. There we've already discussed on how to derive these. Okay. So R is equal to U square sine 2 theta by G. U is initial velocity. T is angle of projection. G is acceleration due to gravity. Please by heart these formulas. Okay. Because for 2 marks, you won't get the time to derive and write. So please, I would say learn and write these formulas. Okay. Next question. Write the expression for centripetal acceleration and explain the terms. What is the formula for centripetal acceleration? Acceleration is equal to v square by r. Yes. Acceleration is equal to v square by r. V square is equal to speed. R is the radius. Okay. Yes. Next, we will look at some questions from. So, 3 chapters already done. Markers from first 3 chapters done. Now we have 4, 5, 6, 7, right? Or 6. Next, we will do questions from laws of motion. Okay. So, what is the first question? Name 2 physical quantities which are defined on the basis of Newton's first law. What is Newton's first law? Newton's first law states that every object stays at rest until and unless an external force acts on it, or every object undergoes motion until and unless external force acts on it. So it is defined based on 2 physical quantities, and those 2 quantities are force and inertia. Okay. So first one, force. Newton's first law says that until and unless a force is applied, the object does not move or the object does not stop. Inertia is what? Inertia is the tendency of an object to stay wherever it is. So if there's a book on a table, the book likes to stay on the table. Only if there is an external force hitting the book or moving the book will move. Yeah. Yeah. So that state, the tendency of an object to do whatever it likes to do, is inertia. For example, when you're sitting on a chair and watching reels, you like to do that forever. Unless and until your mom comes and scolds you and asks you to go study. So your stage where you are happy, that is your moment of inertia. Okay. So force and inertia are both quantities based on Newton's law. Newton's first law. Okay. Next. Write the expression for momentum in vector form and explain its terms. Momentum in vector form is P is equal to mv, where m is the mass of the body and v is its velocity. Okay. Next question. Mention Tesla unit in dimensional formula of momentum. What is the dimensional formula of momentum? So, Mr. G, if you're there in class, I will derive one more dimension. Momentum is what? Mass into velocity. So its unit will be, the unit of mass is kilogram. The unit of velocity is distance by time. So distance by time. Meter divided by second. Okay. So the unit is kilogram meters per second. Right, Tilak, welcome to the lesson. Now next is dimensional formula. How will you derive dimensional formula? Dimensional formula, mass into velocity. Dimension of mass is m. Dimension of velocity is L t raised to minus 1. See, dimension of velocity I already derived in this class itself. Velocity is distance by time, which is L by t, which is L t raised to minus 1. Okay. Are we all good? Did you all start preparation for your midterms? How many of you have prepared well for your midterm and are revising now? How many of you have not even opened your books? Let me know in the chats. Let me know what kind of student you are. Okay. Next question. Next question. Distinguish between mass and weight of a body. What is the difference between mass and weight? So what is the difference between mass and weight? You tell me. See, mass is the amount of stuff in your body. You know, your bones, your muscles, your blood, your everything together. Your kidney, your heart, liver, everything together gives you your mass. Okay. So mass is the amount of matter in you. Okay. The amount of matter in you. Now this mass is pulled down by gravity. Okay. This mass is pulled down by gravity and that is your weight. Okay. So when your mass is pulled down by gravity, that becomes your weight. Okay. Is that clear? Yes. So will your weight change when you go to the or your mass will change? Which one will change? Quickly think and let me know. Yes, very good, very good. Who is that? Yeah, super. Your weight will change when you go to the moon because gravity is going to change. But your mass is not going to change even if you go to Jupiter or Neptune or Uranus. Wherever you go, your weight is mass is going to be the same because it's the amount of matter in you. Okay? That mass multiplied by gravity is giving you weight. This will change depending on the gravity. Okay? Yeah. Next question. Write Newton's second law in component. So generally, what is Newton's second law? Generally, Newton's second law is F is equal to ma. Now, in component form, it will be what? Along x-axis it will be fx is equal to max. Fy is equal to may. Fz is equal to maz. That's all. Okay? Yes. That is Newton's second law in component form. Now, state and explain Newton's first law of motion. What is Newton's first law of motion? If you have a book on a table, okay, if you have a book on a table, I know my table looks very bad, but yeah, imagine there's a book on a table. The book lies on the table forever unless and until some force acts on it. Unless and until you go do this, or you go push the book, okay, or a rat comes and pushes the book. Something or wind pushes it. Something has to move the book. Unless that something comes and pushes the book, it will stay there forever. So that something is basically a force. Okay, so unless force pushes the book, it will stay there forever. Same thing for a body that is in motion. So if you take a ball and you roll a ball, okay, what happens when you roll a ball? This ball is going to stop after some time because of friction. But imagine there is a world with no friction, zero friction. This ball will continue to roll forever. Yeah. Okay. So that is Newton's first law. Next question. Mention the significance of component form of Newton's second law. So what is the significance of writing F is equal to ma as Fx equals max or Fy equals may? The main advantage is you can, analyze the force separately along each axis. You can find out the force along x-axis, y-axis and z-axis. So if you have complex problems, it's easier to solve. Okay. Next is what is impulse? Impulse is basically a large force acting at a very short time. For example, I do this. A huge force acting for seconds is impulse. But if I'm not sitting on the table, I'm keeping my hand on the table for a long time. I am applying force on the table, but that is not impulse. Because I am applying force for a long time. Impulse is big force, short time. For example, You take a book, you hit your friend. Done. That was a lot of force at a very short time. Cricketer hitting a bat, sorry, hitting a ball. Ball comes, tuck, he hits. Yeah. A large force at a very short time is impulse. 8 and 9 questions the same. 10 question. Take next one Newton's third law. All of you know when every action there is an equal and opposite reaction. So when A exerts a force on B exerts equal and opposite force on A. Okay? A pushes B pushes A back. Yeah? Please for your exam, don't example is asked, don't say I slapped my friend, he slapped me back. No. Okay? Yeah? So if you're pushing a wall, what happens? The wall is pushing you back. That's why nothing's moving there. Hmm? Things like that. Okay, next question. Give an example which illustrates the law of conservation of linear momentum. What does linear momentum conservation say? It says that forward force, forward momentum or anti-clockwise momentum is equal to clockwise momentum. So if you have momentum in the forward direction, it is equal to the momentum in the backward direction. For example, recoil of a gun when bullet is fired. What does that mean? So if you're shooting, okay? So when you're shooting, the bullet goes out, there's momentum in forward direction, but the bullet exerts the same force on the gun backwards, which is in the backward direction. So if you're shooting, sometimes if you don't hold two hands, your hand will go like this. That is because the bullet there is a backward force and a forward force. So forward momentum and backward momentum, and they both have the same value. Hello Vishwajit Shetty. Hello, hi. Welcome to the lesson. State the principle of rocket propulsion. How does a rocket move forward? A rocket moves forward by expelling gases backward. Yeah. So the rocket is moving forward, the gases are moving backward. So forward momentum, backward momentum, same. Hence momentum is conserved. Yeah. Next question. Mention the common forces in mechanics. The different forces. Gravitational force, frictional force, normal reaction force, tension force, applied force, blah blah blah. Okay. Now what are normal reaction and friction? So see, if you're standing, hi bye. Okay, Vishwajit says hi and then bye. So imagine you're standing, okay? You have your weight acting downwards and the upward force that's helping you stand straight is called normal reaction. See, if normal reaction was not there, if only weight was there, what would happen? You would sink into the ground, isn't it? But you are not. You're able to stand straight on the ground. That is because normal reaction is there upwards. Okay, same for a book or a table. Normal reaction upwards, weight downwards. What's friction? So if this is the floor, you're walking. You're able to walk properly because friction is supporting you. So friction is basically a force that keeps you in motion. So if you're walking forward, friction tries to pull you back. Yeah. Next, what are contact forces? Give examples for contact force. Contact force is what? Forces acting through direct contact. For example, when I rub my hands, there is friction between my hands. That is a contact force. When my hands get in touch, that is when there is friction. Okay, tension is a force on a string. That is a contact force. Only when there is a string, there is tension. Normal reaction. It's acting on your body. It is a contact force. Okay. Give an example of non-contact force. What are they? Gravity. Even if you're on top of a tree or on the airplane, every time you feel gravity, you don't have to touch the earth to experience gravity. Okay? Next. Sorry. Mention the types of friction. What are the different types of friction? Static friction, kinetic friction. This we've already discussed in which chapter? The same chapter, laws of motion. We discussed the different kinds of friction. What are the different advantages of friction? Without friction, you cannot walk. See, if there's oil on the floor, you will be dancing and you'll fall. Yeah? So without friction, you cannot walk. When you put oil, it reduces friction, so you fall. Imagine there is zero friction, you cannot walk at all. It helps you drive, it helps you write. So you are able to write because your pen, nail, and book has a friction. Okay? Now, the two types of friction. Friction is divided into static and kinetic. Okay? This kinetic is divided into sliding friction and rolling friction. Okay? Kinetic is divided into sliding friction and rolling friction. Now, next question is what is sliding friction? It is the friction between two surfaces sliding over each other. So, if this is sliding friction. If this is the rolling, okay, like this, if it's rolling like a ball, then it's rolling friction. Okay. Last question, I think. No, one numerical question, but last theoretical question. Why is banking of roads necessary? What is banking? Banking is basically when you have a curved road, instead of making it a flat road, you lift it. So it will be curved like this. Instead of curving it like this, you curve it like this. Okay. So if this is your road, instead of going like this, what happens? You lift it. It will go like this. You might have seen these sports cars. They're always laughing. So that is banking. And why should we ban? Because when we ban it, it helps you provide an extra force. It's basically for vehicle safety. So you can go faster without skidding. Okay? So banking of roads also very neatly I've explained in this chapter. Laws of motion. Yeah. Yeah. Next, a constant force of 8 Newton is applied to a body of mass 3 kg. Find the acceleration. Very easy. F is equal to ma. A is equal to F by M H by 3. 2.66. Next question. An object of mass 10 kg accelerates at 2 meters per second square. What is the magnitude of force? So F is equal to ma. 10 into 2, 20. Okay? Yes. A body of mass 1.5 kg has a linear momentum of 6 kg. Find its linear velocity. So momentum is mass into velocity. Velocity is momentum by mass, which is 6 by 1.4, which is 4 meters per second. Please write unit. Without unit, you will lose marks. Okay. Everywhere, please write unit. Okay. Okay. Now coming to the next chapter, work energy power. Yes, work energy power. Are you all ready to do questions from work energy power? Okay. Question number 1. Mention the necessary conditions for work. What is work? I've already taught you this. Work done is force into displacement. So for work to be done, there should be force, there should be displacement. These two things are the necessary conditions. Okay. Second question. State the conditions under which no work is done. Or write the conditions with zero work done. When there is no force, obviously no work is done. And when there is force but the body is not moving, and there is no displacement, then also there is no work done. For example, I keep on pushing a wall. The wall is not moving. I push for 3 days, but still no work is done because there is no movement. So if there is no displacement, then there is no work done. Okay? Yeah? Okay. Next, under what conditions the work done by a force is maximum and minimum? So we already know the formula for work done is what? W is equal to F dot distance S or R, anything. So if it's Fs cos theta. Okay. So for maximum work, what should theta be? If theta is 0, then it will be W is equal to Fs maximum work. Minimum work or 0 work is when theta is 90. So cos 90 will come. Okay. So it just has to be between cos 0 to cos 90. Okay. Okay. Next question. Can acceleration be produced without doing any work? Give an example. What is acceleration? Acceleration is basically accelerating, moving forward with changing velocity. So to do that, do you always need work? That is the question. Okay. So students, the meaning is in circular motion. Okay. In circular motion, yeah, centripetal acceleration acts perpendicular to velocity. So then this is velocity. Okay. Centripetal acceleration, centripetal force is acting towards the center. Okay. So here acceleration is there, but there is no velocity. I mean, there is no work done. Hello, Praveen. Sumit Kumar, voice is not here. Centripetal force is acting towards the center. Okay. So here acceleration is there, but there is no work. Voice is not here today. Yeah, Praveen, after a long time, how are you? Why is voice not here? Is it really bad? Okay. Next is the SI unit of work. See, the SI unit of work is the SI unit of energy itself. One thing that you can remember is energy is equal to work done. Okay, energy transferred. So their SI units and the dimension formula have the same. So it's joule and ml square t raised to minus 2. Next volume not like previous class. I don't know if I'm using the same system. I am speaking with the same sound. I don't know what's wrong. What's wrong? Okay. And dimension is ml square t raised to minus 2. Force into distance. The dimension of force into the dimension of distance. Okay. Okay. What are conservative and non-conservative forces? Conservative forces do not depend on path. So this is A, this is B. You can reach B like this. You can reach B like this. You can reach B like this. However you reach B, it does not matter. The path is not concerned here. However you reach B, the force is conservative force. But non-conservative force depends on path. Okay? So conservative force independent of path. Non-conservative force dependent on path. Okay? Yeah. Next is the SI unit of energy, as I said, same as work done. Okay, joules and ml square t raised to minus 2, these two things are same. Work done and energy, they have the same dimensional formula. Okay, yeah. Now, mechanical energy are two types. Mechanical energy are of two types, kinetic energy and potential energy. So the question is, what is kinetic energy? What is potential energy? Kinetic energy is the energy of a moving object. Potential energy is the energy of an object that is at rest, that is not moving. It is the energy of an object because of its position. Okay. For example, when I'm running, okay, let's say I'm sitting now. My energy is potential energy. The moment I start running, my energy gets converted into kinetic energy. Okay? So kinetic energy is the energy for a body that is moving. Potential energy is the energy for a body that is not moving, but it's at rest at some position. Okay? Okay. Next question. Next question. What is it? Is my voice that bad? Can you let me know in the chat? State and explain force law for the spring. Okay, force law or this question could be Hooke's law. Okay, the question could also be state and explain Hooke's law. So Hooke's law states that force exerted on a spring is directly proportional to the displacement or the extension of the spring. Now, when you remove the proportionality, it becomes minus kx, where k is the spring constant. Okay, so Hooke's law states that the force exerted by the spring is directly proportional and opposite to the displacement. You can also say it's directly proportional to extension. Okay. Now, what is the spring constant K? K basically tells you the stiffness of a spring. So, if K is very high, the spring is stiff. K tells you how stiff it is. And what is the SI unit? So, as I said, F is equal to minus Kx. So, K is equal to F by X minus F has a unit Newton, X has a unit meter. So, the SI unit of spring constant is Newton per meter. Okay. Next question. Draw a graph showing the variation of kinetic energy and potential energy of a spring which obeys Hooke's law. So what you'll do is you will draw x-axis and y-axis, and then you will draw total energy line. This is total energy. Okay. And then this is kinetic energy, and then this is potential energy. You should draw a neat one. That's why I've already put the picture there. So you can see at the center, potential energy is 0, kinetic energy is maximum. Towards the side, kinetic energy is 0, potential energy is maximum. Okay. Mention the different forms of energy. What are the different forms of energy? Mechanical energy, thermal energy, chemical energy, electrical energy, nuclear energy, radiant energy, so many different forms. Now, you might think kinetic and potential. So, kinetic and potential comes under mechanical. Okay. So, under mechanical, there are two kinds of energy, kinetic energy and potential energy. Okay, next question. What is the unit of electrical energy expressed in joules? The unit of electrical energy is kilowatts per, no, not per kilowatt hour. Okay. So 1 kilowatt hour is 3.6 into 10 raised to 6 joules. Okay. Yes. Next question. Which physical quantity is measured in HP? Express it in SI units. HP is basically horsepower. Okay. So power is represented by horsepower. The standard unit of power is watt. Okay. But horsepower is also another unit of power. 1 horsepower is 756 watts. Right? Yes. Next question. Write the SI unit and dimensional formula for work. So dimensional formula for power is what? Power is equal to work done by time or energy by time. Energy by time. So energy, we already know what was the dimension. ml square t raised to minus 2. Yeah. How much was it? I don't want to derive it now. Yeah, ml square e raised to minus 2. Yes. Ml square e raised to minus 2. So this divided by t, what happens? It goes up, this becomes e raised to minus 3. Okay? Next question. Show that P is equal to S into V, where the symbols have their usual meaning. Okay. So first thing let's do, let's use the formula. So we know that power is equal to work done by time. So change in power is what? dW by dt. Now we also know that work done is what? Force into displacement. Yes. So force I'll take outside. This becomes ds by dt. ds by dt is what? Velocity. So this becomes F into V. That's all. As easy as that. Okay. So now the neat version I put here. Okay. Yes. Next question is about collisions. What are the two types of collisions? Elastic collision and inelastic collision. What is elastic collision? A collision where kinetic energy is conserved. What is inelastic collision? A collision where kinetic energy is not conserved. Okay, so these are the two collisions: elastic collision and inelastic collision. Now, if you are asked to distinguish between an elastic collision and inelastic collision, what will you say? You say that in one kinetic energy is conserved, in the other kinetic energy is not conserved. Kinetic energy decreases. Okay? Yes. Okay. Fast force of 8 Newton is applied to a body which displacing it through a distance of 9 meters in the direction of the applied force. Find the work done. Very easy. What is work done? F dot S, which is Fs cos theta. So this is basically 8 into 9 into cos theta will be what? Cos theta will be 1. Why? Because they're both parallel, they're both in the same direction. So what is the angle between them? 0. So you have to take cos theta. You just have to do 8 into 9. Next question. An object of mass 10 kilograms moves with a speed of 5 meters per second. Estimate the kinetic energy associated with the object. Estimate the kinetic energy associated with the object. So kinetic energy is equal to half mv square, which is half into 10 into 5 square, which is 5 into 25, 125 joules. Yeah, that is the answer. The answer is 125 joules. Okay, okay. Two more chapters to go, students. Just two more chapters. Okay, just two more chapters. Yeah. So, system of particles and gravitation. Quickly, let's finish these two more chapters. Is my voice clear, students? Can you all quickly just let me know? Hello, hello. Okay. So next question, next chapter is system of particles and rotational motion. Okay. Question. Pure, okay, there is no the here. What is pure translation motion? Give one example. So what is pure translation motion? Pure translation motion is when all the particles of a body move in parallel paths with the same velocity. Okay? So we have five objects, they five move with the same velocity. For example, a sliding book on a table. Okay, so this is a table and this is a sliding book. Pure translation motion. Okay? Then what is pure rotational motion? Is when an object rotates about a fixed axis, a spinning wheel. Okay? If the rotation is fixed about one axis, then it's pure rotational. Okay? Pure translational, pure rotational. Next question. Give an example for a body whose center of mass lies inside the body and outside the body. So if you take a sphere, you take a big sphere, the center of mass is where? In the center. What is center of mass? The point where the mass is the same through all the directions. That is inside the sphere. Now if you take a ring, I don't have a ring with me. You take a ring. Okay? You take a ring like this. The center of mass is also the center. For a ring, the center of mass is at the center. But it's not touching the ring. It's just at the center of the ring. So it's outside the body. Okay? Next question. What is a mechanical advantage of a lever? Okay? The mechanical advantage of a lever is greater than 1. What does that mean? So the question is MA greater than 1. What does that mean? So mechanical advantage of a lever is basically a ratio. The ratio of what all? Output force by input force. Output force is what? So if you're lifting a rock, the rock is your output. The force that you apply is the input. Okay. So how are you able to lift the rock using a lever? Even if you apply a small force, you are able to lift the rock because your force multiplies. So MA greater than 1 means by applying small force, you can do a lot of work. Yeah. So you can lift very heavy objects with very little effort. That is the meaning of MA greater than 1. Yeah. You can just read what I have written down here if you want to know more about this. Same thing I explained, but yeah. Next question. Define vector product of two vectors. Scalar product or dot product we already discussed. Vector product is what? A cross B. Okay? C is equal to A cross B is vector product. Now A cross B means what? A cross B means AB sine theta. A into B into the angle between them. A into B times the sine of the angle between them. Okay? Yes. Is that clear for all of you? Okay? Good. A dot B and the angle between them. Now there's one more part of the question. Give an example. Give an example. So what is an example? I will take the example of a torque. Yeah. So torque is tau. So torque is basically the position vector R times the force applied F. Okay. The torque is basically R cross F. So which is RF sin theta. So its torque is along the direction and the force. So R cross F. Okay. Next question, that is give me 2 minutes, students. I'll just be back. Okay. No clarity. No, there is clarity on my screen. I think it's your internet, dear. If you can do, can you just change, go to your settings and change quality? Then it might be better. Yeah, yeah, let's continue. Sorry for that. Define moment of force. What is moment of force? Write the expression for it. So moment is basically moment or torque, which is the turning effect, is basically force into perpendicular distance from the pivot. Force into perpendicular distance from the pivot. What is the meaning of that? I'll draw it and show you. This is the pivot. What is pivot? Pivot is the point at which there is the turning force happening. So, for example, if it's a door, you're opening the door like this. Okay, this is the door knob, you're opening the door like this. This is the pivot. The point where the turning effect takes place is your pivot. If you're sitting on a seesaw, you all have played in seesaw in your school, no? Or in parks. This is how seesaw moves. You sit here, your friend sits here, and you move like this. So this point is the pivot. Pivot is the point where the turning takes place. Okay? And let's say you apply force here. This is the distance R. So the distance R into force gives me my moment. Okay? Yes. Okay. Next question. Mention two factors on which torque of a rotating body depends. Torque depends on two factors. What are the two factors? It depends on the amount of force and the perpendicular distance. As I told you in this figure, depends on the force that's applied and the distance between force and the pivot. Okay. So for example, this is my rotation. This is my pivot from my pivot till my force. This distance and how much force I am applying. Okay, what is the meaning of that? Students, let's say, imagine this is the door. You open the door like this. You open the door by holding it here. Can you open the door by holding it here? It will be very difficult. No. You can't open the door by holding it here also. It's easiest to open the door by holding it here. That is because you are away from the pivot. So more the distance from the pivot, easier to open the door. Okay. So torque depends on two things, force and distance from the axis of rotation or from the pivot. Okay. Okay. Next question. Define angular momentum. Write the expression for it. Define angular momentum. Write the expression for it. So you can, in simple words, you can say linear momentum is what for an object moving in a straight path. Angular momentum is for an object that is moving in a rotational path. Okay. So angular momentum is what? It is the rotational version of linear momentum. Okay. Angular momentum is the oh, angular momentum is the rotational equivalent of linear momentum. Okay. It measures how much an object is rotating about a point or axis. For example, it is defined as the vector product of the position, blah blah blah. All that is not required. Okay. You can also say that for hello Subhalakshmi, welcome to the lesson. For a rigid body rotating about a fixed axis, angular momentum is given by L is equal to I omega. That much is enough for 2 marks. Okay. Yes. Next, write the dimension and SI unit of angular momentum. So what is the formula for angular momentum is? L is equal to I omega. I is inertia, omega is velocity. Okay. So combining that you will get kilogram meter square per second dimension will be ml square t raised to minus 1. Okay. Omega is angular velocity. I is moment of inertia. Next question. State and explain the principle of conservation of angular momentum. What is the principle of conservation of angular momentum? If no torque exists, the angular momentum remains constant. This means rotational motion is conserved. What is the meaning of that? Something, man, what is all this? So let me you call me ma'am. If you did you want to say hi? See, let's say there's a system. If there is an external torque on the system, what happens? It will rotate. Some way it will rotate. Okay? Now if there is no external torque, it will not rotate. If something does not rotate, it has no angular momentum, no rotational motion. Yeah? So if there is no external torque, rotational motion is conserved. Okay? Now, two examples of conservation of angular momentum. What are they? Spinning of ice skater pulling in arms to spin faster or revolving around the sun. See, you see ice skaters spinning. What they do is they close their arms so that they can spin faster. Okay, that is one example. And the earth revolving around the sun is another example. No clarity. Are you talking about the audio, dear? Yeah, I think my audio is. Are you talking about my audio clarity, Subhalakshmi? Yeah, I think my audio. Just define moment of inertia. Moment of inertia is what? It is the rotational mass. I is mr square, m is mass, r is distance. This we've already discussed. SI unit is kilogram meter square. Okay. Mention two factors on which moment of inertia of a rigid body depends. Obviously, it depends on the mass. It also depends on the distribution of mass relative to the axis of rotation. How much mass is there along that one axis? Hello, Shivani. Shivani, can you let me know if my audio is clear? Because some students are saying my audio is not clear. Define couple. Give the expression for moment of a couple. What is a couple? Couple is basically two equal and opposite parallel forces that produce rotation. So if this is rotating like this, it is because there's one force in this side and one force in this side that makes it rotate. Okay? Moment of force is the same force into D. It's not clear. Okay. What do I do? Is it a little better? Is it a little more better? Two examples for couples are turning a steering wheel, opening a door using a handle. Let me check on my phone if it's clear. don't think it's clear. Okay. Anyways, I've typed out the notes, so even if you're not understanding what I say, you can go through this. Okay. Still there is glitch. I'm not very sure about why, but I'll figure it out before next class. Next question, state the principle of moment. What is the mechanical advantage? Principle of moment states that clockwise moment is equal to anti-clockwise moment. Okay, so for as I said, for a seesaw, okay, imagine there is the seesaw is standing straight, which means the person on this side and the person on this side they have the same moment, which means they have their mass into distance is equal. Mass into distance for a person on this side is equal to mass into distance for person on that side. Okay, audio is not clear. Give the general conditions for equilibrium. For equilibrium, so net force should be zero, net torque on the body should be zero. So Balakshmi, audio is not clear. Why is this happening to live classes? Hmm. Oh, feel bad. Ma'am, Puriela. Okay, anyways, let's finish this off. All the content is typed out, so you can go through that as well. Yeah. Why a flywheel is used in engines of vehicles? So it stores rotational energy. Okay. Flywheel stores rotational energy. What are the factors on which moment of inertia of a body depends? It depends on the mass, shape, and the axis of rotation. Okay, so moment of inertia depends on mass, shape, and axis of rotation. Question. To maintain a rotor at a uniform angular speed of 200 radians, an engine needs to transmit a torque of 180 Newton meter. What is the power required? So power is basically torque into speed. 180 into 200, it will be 36 kilowatts. Yeah, 180 Newton per meter, 280. Okay, then this is the last chapter, gravitation. I feel very sad, no? If my audio is not clear, then you wouldn't be able to understand my class. That's very bad. That's very sad. Okay, anyways, question. Why moon has no atmosphere and why? So moon has very weak gravitational force. See, why do we have an atmosphere? That is because the Earth is able to hold the atmosphere. It has gravity, but moon has no gravity, so it is not able to hold the atmosphere. So it does not have an atmosphere. Okay. Define gravitational potential energy of a body. Give an expression for it. As I said, gravitational potential energy is the energy of a body because of its position. Okay, and it's given by U is equal to minus gmm by r. G is called gravitational constant. M is the mass of the earth. Small m is the mass of a body. R is the distance from the center of the earth. Next, state and explain Newton's laws of gravitation. Okay, state and explain Newton's laws of gravitation. Karthik, thank you. What are different Newton's laws of gravitation? Every particle attracts every other particle with a force. Okay, so this force is proportional to the product of their masses. It's inversely proportional to the square of the distance between them. Hi Karthik. So let's say this is mass 1, mass 2. They're separated by a distance r. The force experienced by mass 1 and mass 2 is basically proportional to mass 1 into mass 2 divided by the distance between them, which is r. Excuse me. Okay. What escape speed give its value in the case of Earth? Okay. Escape speed is the minimum speed needed to leave Earth's or planet's gravitational field without further propulsion. So if the speed, okay, so that means a rocket comes out of the earth, out of the atmosphere with an escape speed, okay. So if only if the rocket overcomes its value of escape speed, then it can come out of the atmosphere. And for Earth, the value is usually 11.2 kilometers per second. Okay. Since the audio is not that clear, I will just finish it off. Okay, probably in another class we'll do a detailed version. Next question. Define orbital speed of a satellite around the Earth. Write the expression for it. What is orbital speed? Orbital speed is the speed at which the satellite moves around the Earth in a circular orbit. Okay, the maximum speed by which a satellite moves around the Earth is orbital. Okay, next question. Why does an object weigh more at the surface of the Earth than at any point inside the Earth? Why? Because weight depends on gravity. Okay. So Earth gravity decreases with depth inside the Earth. Yeah. So weight is maximum at the surface, and as you go inside, it reduces because gravity is reduced. Very easy. Next question. What is a satellite? Name the natural satellite of Earth. A satellite is just a body that revolves around another body under gravitational force. Okay. The natural satellite of Earth is the moon. Give two applications of artificial satellites. What are they? Communication, weather forecasting, television broadcasting. You can write on any. Okay, any are fine. Next. Next is what? The both radius and mass of a planet are 2 times that of Earth's values. Calculate the acceleration due to gravity on the surface of the planet. Let's do that. So we know that gravity is equal to Gm by r square. Yeah, gravity is equal to Gm by r square. Now, mass is equal to 2 times mass of the earth, and radius is equal to 2 times radius of the earth. So now the formula will be G dash is equal to G times 2me divided by 2RE square. Instead of M and R, I'll substitute 2ME and 2RE. So 2 and 2 will cancel. So this is basically GME divided by Thank you so much, King of Cards. Please share this video to all your friends so we can grow as a channel and give you more content like this. Okay? Very square. So G times 2ME, the whole divided by, what am I writing? 4 2RE square. This is 4RE square. Okay? Now, GM by RE, I'll write it as GE. Okay? So, GMRE, these three together, I will write it as G. So, this will be equal to 2 by 4 G, which is 1 by 2 G, which is 1 by 2 into gravity, which is 4.9. Okay, thank you so much, King of Cards. That's all that we want. Okay, your likes, your shares, and your subscriptions. So please do like, share, and subscribe and support us. Next question. The radius of the Earth is RE. Find the depth at which the acceleration due to gravity is half the acceleration due to gravity at the surface. Okay. So we already know gravity, the depth is what? G into 1 minus d by RE. Yeah. And this is equal to G by 2. Okay. So G and G cancels. So we have 1 minus d by RE is equal to 1 by 2. Okay. So from this we will get d by RE is equal to 1 by 2. D is equal to RE by 2. Okay. Yes. Okay. With that, we come to an end of our 2-marker series for midterm physics. Yes. Please explain system of particles and rotational motion. Sir, Sumit, I will try to do a class on system of particles and rotational motion. Don't worry, okay? Yeah? But for that, I need your support. So only if this video reaches at least, 100 likes, yeah, then we can do more chapters. So quickly, can you all quickly share this channel to all your friends and make sure everybody subscribes and likes to this so we can keep doing this. Yeah? Your support means a lot to all of us. Okay? Thank you so much. Please let me know in the comments how the class was. I think my audio is not that great and I really don't know why. I'm really, really sorry for that, students. Next class, I'll make sure my audio is good. Okay? Thank you for watching. I will see you all with another fantastic class. Until then, bye-bye.